So you're using the laptop for this one?
Yeah. I'll play a game through that one though, but it won't record.
Yeah. I'm still waiting game at the moment.
That's all right. Good to go. You, I forgot it.
You got it again?
I know. I figured I went thing. Oh my god. His pillow.
But that favorite thing.
He needs a pillow. Yes, they're very crumbly though. So they'll create a mess.
And it's lower, not upside down. Oh, that is what he, there goes from the. Oh. Yeah.
Sorry?
Thanks.
Good try.
I know.
Yeah, I didn't do much of that as well.
Is it stuffed?
No, it's just taking a little bit of time to start up.
Yeah, it's not right. It's Monday. You're just like, really like. Oh, no. I'm dead. I don't know. You're getting much really new. It's okay, we all ready to meet. How did everybody find without just kids? No. No. Yeah, that's kind of long recording here, actually. A long image. Pretty low, can chocolate very extreme. You won't get the advantage of it, but. We're gonna start just populating, just thinking about the elements of the diamond. It's like, it's not like the filing system, I don't think. So like a great big tube where stuff gets broken down, stuff gets added to it. And then you get a waste, stuff gets absorbed, used by cells, and then we get a waste product called feces. So what I want you to do, it looks like everybody apart from Dan has a friend sitting beside them. What I want you to do is go through the elements of the digestive tract. I'm going to start you with the oral cavity. I want you to identify the accessory gland of the oral cavity to begin with. I've got three things that I want you to do. What happens in the oral cavity in terms of food, what the accessory gland is, what it secretes, and what's the purpose of that secretion. And I've got a question for you. Why would the oral cavity be lined with moist, stratified squamous epithelium? I'll go at that between your little groups. You can read your notes if you like. And feel free to eat more cake. We're talking about digestion. Okay, so what's happening in the oral cavity? We don't understand anything. Chewing. Know the real name of chewing? Mastication, yes. So what does chewing involve? Teeth? Yeah, teeth and your tongue. So what happens when we chew we create something called a bolus, BOLUS. It's a bolus of food that we then, we're going with black screen today, by the way. The bolus of food is what's ingested into the stomach, isn't it? Anyone tell me what leaves the stomach? So we make a bolus of food, but through chewing chyme or chyme. Yeah, I don't mind what you call it, but yeah, that's it. And it is really important for everyone that you use the correct terminology. The bolus goes in, the chyme comes out of the stomach into the duodenum, right? Okay, so we've got mastication occurring in the mouth. What's the purpose of it? Create the bolus, but also to do something else. Somebody said it.
Increase surface area.
Yeah, increase surface area then for digestive enzymes to be able to, you know, come in contact with the food. All right, what's the accessory gland of the mouth? It's a gland, it secretes something, a liquid. Some of you may be producing it right now. Thinking about your dinner or thinking about the cakes. Saliva, yeah. So saliva is produced by salivary glands. And anyone give me a, don't really need this microphone. Anybody give me a function of saliva? Did you say lubrication? Yes, beautiful. So lubricates food and helps to form that bolus, yeah? What else does it do?
Enzymes, breakdown.
Yeah, which one?
One person starch.
Yeah, so when you eat pasta or bread or all those yummy big sort of starchy foods, salivary amylase will begin the process of starch breakdown. And what it does is it breaks complex polysaccharides down to things like maltose, right? And it's that breaking down and producing the maltose that gives us that really sweet taste of bread in our mouths. So salivary amylase, what else is in saliva? Anybody know? Slightly alkaline, and that's why salivary amylase works. There's also a little bit of lipase. So lingual lipase doesn't do much in the mouth, and pretty much, you know, food doesn't tend to hang around in your mouth for very long, does it? So there's not that much digestion going on. But there is something called secretory IgA in saliva. So immunoglobulin A, so it's going to have antimicrobial effect and also lysozyme as well. Okay. All right, so we've got this bolus of food. Oh yes, why have we got stratified squamous epithelium? So lots of layers of flat, moist epithelial cells. Anyone? Because you're going to put lots of things in your mouth, hot coffees, cold ice creams, acidic fruits, alkaline, you know, vegetables and stuff. So it's there for protection and to protect against abrasion, right? Okay, so from the mouth, where does the bolus go? Anyone? A straight tube called the... If you were from America, and I'll never forget, I had a lecturer who was from America, and he used to, the first time he came in, he called it the esophagus. And we were like, what the hell is the esophagus? It's the esophagus. Okay, so we get the bolus traveling down the esophagus to the stomach. There are two sphincters in the esophagus. I want you to... Actually, let's do something a bit more than just repeating sort of the content. I want you to think about mucus to begin with. And mucus pretty much lines the whole digestive tract. I want you to imagine, Patrick, that you don't have any mucus. So what would Patrick be at risk of? And Jack sitting beside Patrick, his sphincters along the whole digestive tract are not working properly. So what is going to be the issue with these two, Patrick and Jack, in terms of sphincters not working and no mucus? Take the two questions independently of each other. Hello, we have no communications. Okay, so let's start with the mucus question. If you don't have mucus lining your digestive tract, what's going to happen? And it depends on the location in the digestive tract. Can you use that? Stomach ulcers, yeah. Do you want to explain how that happens? No, you're dead right. Okay, so people can get stomach ulcers if there's a breach or there is insufficient mucus being formed. It's a really thick alkaline mucus that protects the mucosal layer of the stomach wall. But in fact, if you breach the mucosal layer and it's sort of caustic, sort of burning through, those stomach ulcers can penetrate the whole wall, and that's really disgusting then, because all the contents of that acidic chine can get into the peritoneum, and then that's obviously life-threatening because you can get really nasty infections in there. How do you think you might lose your mucus lining in your stomach? If you've ever had a stomach ulcer, you might have found out why you got it, or your parents had a stomach ulcer. The most common one is that bacteria that I mentioned to you before, Helicobacter pylori, but also overuse of drugs like Nurofen, aspirin, those non-steroidal anti-inflammatory drugs, because what they do is they block prostaglandin production. And that's good if you've got inflammation, right? Because it's acting as an anti-inflammatory. By blocking the prostaglandins, they drive inflammation. But also prostaglandins are responsible for forming the mucus layer in the stomach. So if you block that, in some people, that blocks that mucus production, and the non-steroidals can then cause the stomach ulcers. Does that make sense? Particularly aspirin, because aspirin's acidic as well, and it can just aggravate, the acid can aggravate the stomach wall anyway, which in normal circumstances will stimulate more mucus production. But if you're using non-steroidals, then you can run into a bit of trouble. Okay, what else about mucus? If you don't have it lining the other parts, you're going to lose that lubricating effect. Also, stuff passing through passageways will be abrasive, so that's not a good thing either. So damage to mucosal cells. Okay, Patrick, sorry, we're finished with you, Patrick. Jack's sphincters are not working properly. Okay, so in the esophagus, we have the upper and lower esophageal sphincters. So if his lower esophageal sphincter is not working properly, what might he have? Huh? Heartburn, yeah. Yeah, so gastric reflux, and that can develop then into that GORD, or gastroesophageal reflux disorder. What about his pyloric sphincter? What might happen if that doesn't work properly? Let's say it's weak, okay? So if it's kind of open all the time, you're gonna have food rushing out of the stomach before it's digested, aren't you? And so it's gonna lead to things like diarrhea and all of that. If it's stenosed or narrowed, or if it won't relax properly, then you're gonna get backup of that chyme in the stomach. It's not gonna pass through as it should. And that can cause nausea and constipation and all sorts of things. What about a leaky ileocecal sphincter valve? Same thing. You're going to have stuff not getting digested properly and rushing through the digestive tract, right? Okay. All right. So we've got our bolus entering the stomach. We've got what happens in the stomach. Does carbohydrate get digested? No. So the acid in the stomach is going to inactivate salivary amylase. So no carbohydrate digestion in the stomach. What else will happen with the hydrochloric acid? Anybody? Going to cause protein denaturation, right? Yeah. And it's going to activate something. Anybody know what that's called? What gets digested in the stomach? Begins with a P. Proteins. Protein digestion starts in the stomach and it ends in the small intestine. And there is an enzyme in the stomach that gets activated because when you think of enzymes that split proteins, so they're proteolytic, they're really powerful, right? So you don't want them being released in an active form because they're kind of going to digest the cells that are producing them. So they get released in an inactive form, and it's called pepsinogen, and hydrochloric acid converts pepsinogen to pepsin. And then pepsin starts the breakdown of proteins into polypeptide chains, right? Okay, you also have a bit of gastric lipase in there, but it's all about the pepsin. And it's all about mechanical mixing as well, right? So remember, you have chemical digestion and mechanical digestion. Chewing is a form of mechanical digestion, but so is the churning in the stomach. It's like a great big mixing chamber, right? And because it's a big mixing chamber, it has in the muscularis layer an extra layer of muscle to be able to do that, okay? All right, so that's about it in the stomach. We're off now. We've got our chyme entering the pyloric canal, then the pyloric sphincter relaxes and some of that chyme enters the duodenum, yeah? What's going to happen in the duodenum? Very small, the duodenum, yeah? Compared to the rest of the small intestine. Yeah, nuts, very good. So if you think about, it's really small. If you think, anybody been to New York? Anyone? Has anyone been to New York? You think about Manhattan, it's tiny, but it's very, very, very busy. And that's the way I like to think about the duodenum. Okay, so yes, all the pancreatic juices are going to enter the duodenum, and that includes bicarbonate. And I'm going to ask you to now tell the person beside you what pancreatic enzymes come in. And also bile. Bile is made in the liver. Where is it stored? Where's your bile stored? So it's made in the liver. Anyone? The gallbladder, yeah. And it's stored and concentrated in the gallbladder, and then it's released into the duodenum when the gallbladder contracts. So Can we start naming these pancreatic enzymes, everybody? What do you think comes out of the pancreas? So don't say insulin and glucagon because they're the hormones, right? But we have enzymes. Wow. Anyone? Everything happens in the small intestine. We get pancreatic amylase, continues carbohydrate breakdown. We've got nucleases that are breaking down DNA and RNA. We've got a whole bunch of enzymes that break proteins down. Can anybody tell me what they're called? And you can see that two of them have an ogen at the end of their name, and one of them has a pro at the start of its name, which means again that they are being released in an inactive form because they're going to digest the tissues that are secreting them if they're released in an active form. Can anyone give me the first one? It begins with a T. Trypsinogen. Yeah, can anyone remember that? And chymotrypsinogen and procarboxypeptidase. Yeah. Now this is where it gets really hectic because there's also these little enzymes that are present on the little microscopic villi that extend from the epithelial cells that line the duodenum. And it's called a brush border, and one of those is enterokinase, and it activates trypsinogen to trypsin, and trypsin activates chymotrypsinogen to chymotrypsin, and also the other one, procarboxypeptidase to carboxypeptidase, and they all continue the breakdown of proteins to smaller polypeptide chains, and then finally we end up with tripeptides, dipeptides, and single amino acids. Okay. What else might occur in this? Okay, what I want you to do now is think about bile. It's made in the liver. What is the purpose of your bile? It's pretty gross if you ever have a very bad bout of vomiting and you end up vomiting up bile. It's pretty, you'll know all about it. It's pretty horrible. Okay, but what does bile actually do? It's kind of an excretory product from the liver. It contains, remember we talked about the breakdown products of hemoglobin? And we talked about bilirubin. Yeah, so that's in there. There's bile salts, there's cholesterol, there's some fat-soluble vitamins. Anybody know what it does? We'll do it on Wednesday in the tute. It doesn't actually break anything down, but it causes emulsification, right? So what it does is it will create smaller lipid droplets out of bigger ones by surrounding the lipids. And that will then increase the surface area then to allow pancreatic lipase to continue the breakdown of lipids. Okay, now I want you to think of a situation where some of your relatives may have had gallstones, which are stones that form in the gallbladder. There are situations that make them more likely to form, and one of those situations is drastic dieting, where you change the kind of ratio of cholesterol to bile salts, and that can cause them to precipitate out of solution, form these big stones, right? There are sort of factors, I think they're called, I can't remember now off the top of my head, but they're called the 5 Fs
that make you more likely to have a gallstone. And I think it's being female is the first F, being in your 40s, being large, and you know what the F word is for that. Still being fertile, and there's another one that I can't remember. Female, fat, fertile. Yeah, the last one's gone. But yes, so if you do go into a GP and explain of pain, and then they kind of, particularly after eating a rich meal, and then they, you know, ask, well, they'll do some observations. And if you meet those 5 Fs, then they might suspect a gallstone. Okay, so bile emulsifies fats. All right, so we're ready in the small intestine now. We've got these little cells that have extensions on them, and those extensions being the villi, and at the end of the villi we have microscopic extensions that makes the surface area of the small intestine enormous, right? And the purpose of that is for allowing all of the food, the chyme and everything to come into contact with the enzymes that are coming from the pancreas, and also the brush border of the microvilli, and also then for absorption to occur. Now, using your knowledge of everything that we've done in this subject before, think about proteins, think about carbohydrates, and think about fats and how they differ, and why one would be absorbed into lymphatic vessels, whereas the other 2 get absorbed into capillaries. So have a think about that and give me the answer. Okay, so which one goes into the little lacteals? Would it be monosaccharides such as glucose or amino acids? Or would it be fat digestion? So, anyone? Which nutrients get absorbed straight into capillaries? And which one goes into a lymphatic vessel? The tiniest lymphatic vessel being those lacteals. So the fatty acids go into the lymphatic vessel, and the other 2 can be absorbed straight into the blood capillaries because they're water soluble, whereas the fats are not. And eventually the lacteals will join up with larger lymphatic vessels, and they will then, you know, move into the venous circulation that way. Okay, so that's all of the kind of structures of the digestive system. Anybody want to have a go at explaining peristalsis to the person beside them? And also segmental contractions, as well as, you might need to look this up, deglutition. Thinking about what that is. Pardon? Swallowing. Yeah, very good. So deglutition is the process of swallowing. So moving from the pharynx into the esophagus is deglutition, and it does involve lots of different structures. Now, the other one, what was the other one I said? Peristalsis. Gail, you look like you're ready to answer.
Smooth muscular contractions in the esophagus, so it's like a contraction that pushes the pelvis further down.
Yeah.
Is it involuntary?
So you get contraction followed by relaxation, contraction, relaxation. It's a little like having a ball inside a stocking and you kind of push it through. Yeah, very good. So, yeah, and you're right. Some of those waves of peristalsis are really powerful, and they are in the esophagus and also in the stomach as well. And you're also right about which part of the esophagus is striated. Would it be the inferior or the superior? Superior part, yeah. So the first part of swallowing is under conscious control, and then the latter part unconscious control. Okay, what about these segmental contractions? Where might you find them happening and what are they? So keep in mind, you will be quizzed on some of this in the final exam. Deglutition is moving stuff along. So is peristalsis, moving stuff along. Mass movements in the large intestine, they're still kind of like peristaltic, but they're they don't happen as frequently, but they move the chyme in like big distances, right? So they're all propulsive sort of modes of transport, but segmental is a little bit different. So just think about that and where you might find it particularly. In the small intestine. Yeah. And they're just sort of repeated sort of contraction and relaxation of smooth muscle that sort of spreads the chyme out rather than moving it along. And so as it's spreading it out, it's becoming more dilute, but it's also coming in contact with the bile, with the bicarbonate from the pancreas, and with all of those enzymes that come from the pancreas, and also the enzymes that form the brush border of the mucosal epithelial layer. Okay. All right. I think I'm going to let you go, everybody. It's 3:05. I think some people need to watch the recordings before the shoot, and we will go through a lot of this stuff on Wednesday. So you will be up to speed today. But all those things that I've mentioned, make sure you're all on top of that for the final exam. Really important to know about the mucus, really important to know about the sphincters and what's happening in each region of the digestive. All right, can you finish the case before you go? Thank you. And I'm sorry about this, but I don't know what's going on. Hi.
Yeah.
Really bad. Yeah, we'll do that on Wednesday in the shoot. Not at all. All you really need to know. You did? Glycolysis and all that sort of stuff. No, we decided a long time ago that you didn't need to know that. People who are in exercise science, you might do. Oh no, yeah, if you transfer, you won't do it in first year. So you need a citrus prep cycle.
Yeah, because we did that.
Electron transport. Well, then you'd be all over it, but we don't. It's too hard to teach people from scratch.
Yeah, I was going to say what we have to do.
No, all we want you to know is the three.
Yeah.
We want you to know about aerobic respiration and anaerobic respiration, just what they mean. and then how many ATPs are produced from each one.
Because I was gonna say, there's an anything that they like. Pressed on.
Yes.
Yeah. So yeah, because I did it twice. I did it again.
Oh, I remember doing it, it nearly killed me.
No, I don't get it.
That electron transport chain, I could see it flashing up in front of my eyes. But yeah, you don't need to know. I know, yeah.
It's the last week before exams that are.
Is it revision?
Yeah, in the last week before exams, because it's not, I noticed that it's now, it's kind of like, everything goes, like now's week 12, everything goes up week 14, and then in 2 weeks from now, it's like, that's like for the exams, it's not like a week break.
So we do the tutorial on genetics in the last week, and there'll probably be room there.
Ah, genetics. It's the inheritance. Yeah. Yeah, okay.
And if you've done it at school.
Yeah.
Yeah.
But there's no break between exams and classes.
No, I don't know how.
I thought that was normal.
Oh, you-
Last week.
What about with Adam? Did you go right up to the
I
last?
think we're gonna have to go right up. It's a couple of sessions, like last week, we didn't have a shoot not before. We had to skip like that was part of it, so then we put that 2 weeks after. So I remember that one.
Yeah, right.
Yeah,
Are you doing 172?
yeah. I'm not sure if that's not actually.
Huh?
I should have read that.
Oh,
But no.
yeah. No, it's unfortunate because they're just big subjects. They just go right up to the wire.
Yeah, right.
So.
I just thought it was gonna have like a 2 week break.
Oh, I hit a record. I found an exam question with 4,600 characters in it.
For us.
Yeah, I've been doing 4,652 characters that was written in 35 seconds.
Oh.
And I thought, yeah, right.
35.
It's possible.
You reckon?
Was it one?
No, it wasn't anybody in Albury, thank goodness. Yeah, I'm really sorry about this. I don't know